Hello and welcome everyone. My name is Diego and in this video we are going to attempt to repair this instrument. This is an old 2-channel digital scope and multimeter made by Fluke. This particular model has an analog bandwidth of 50 MHz. However, its real-time sampling it's only 20 megasamples per second. Unfortunately, the instrument is completely dead. It does not display anything on the LCD nor make any noises when we try to power it on, in spite of it being properly powered. So, after this first external inspection, let's crack it open and see what's going on. The instrument contains two boards, an analog board which is screwed to the bottom cover and a digital board screwed to the top cover. On the one hand, the analog board contains the analog front-end circuits for the BNC and banana inputs, the ADC and the power supply circuits. On the other hand, the digital board contains the digital processor, memory, the trigger circuitry and LCD related circuits. Just after opening it, I realized that one of the electrolytic capacitors from the digital board has leaked. So I replaced this cap and the other three next to him because they also turned out to be bad. The ESR readings were well above a normal value. This is a 10 microfarads capacitor and it has an ESR over 100 ohms, and the other three had the same problem. See, 100 ohms, 500 ohms, and 150 ohms. Unfortunately, after replacing these 4 bad caps, the scope is still completely dead. So let's have a look at the schematic in order to start troubleshooting it. The power supply contains several DC to DC converters to generate the different voltage rails. Plus and minus 5 volts, minus 30 and minus 8 volts. However, when the instrument is switched off, only the first DC to DC converter is on. The first converter is composed of a switching transistor, a switch controller, an inductor, and an output capacitor. This DC to DC converter transforms the minus 15 volts coming from the DC input jack into minus 8 volts to charge the battery and power the rest of the converters. So let's measure if we have minus 8 volts at the output. At the input we have, of course, plus 15 volts from the DC jack, but let's check if we have minus 8 volts from the first DC to DC converter. And we do have minus 8 volts. In order to further continue troubleshooting, let's have a look again at the schematic. According to the service manual, when the on-off key is pressed, the signal power on from the digital board will become high. This will turn on this transistor and power on the rest of the DC to DC converters. So before continuing, let's check if this signal is generated when the on-off key is pressed. Well, we might have found something, because the power on signal is not appearing when the power on key is pressed. So let's check the circuit responsible for generating this signal and figure out why it is not working. The on-off circuit is located in the digital board. When the on-off key is pressed, this node is pulled to ground. Therefore, this transistor starts conducting and also makes this other transistor conduct. And finally, the power on signal becomes high. Since this part of the circuit is not working, let's measure if the VRAM power signal is present. I have just measured it and we don't have a VRAM power signal. So the next step is to check the VRAM generating circuit. The RAM power circuit is a simple oscillator that is built with an AND gate. The other three gates from the IC are used as a buffer. The buffered output of the oscillator is rectified and low-pass filtered to give us the desired DC voltage. The output voltage is fed back through these transistors to subtract a voltage gap. When the output has reached the right value, it stops the oscillator. Since we have a test point here, let's measure the filtered output of the oscillator. And it seems to be working. Here it's the output directly from the oscillator, which is a square wave, and in pin number 4, for example, we should have the same square wave as in pin number 3. And we have nothing at all. Well, I think we have found the problem. Some of the gates in this IC seems to be bad. In order to double check, let's feed an external voltage at VRAM and see if we can turn on the scope. And moment of truth. And it works. So let's order a replacement IC and finish this repair. Well, I hope that you have enjoyed the repair video. Thank you for your attention.